Hi, in today's video we are going to look at the June 2005 paper 1 past paper for CSEC Chemistry. Let us begin. Which of the following techniques or processes may be used to separate a mixture of plant pigments into its individual components? A. Fractional distillation. Fractional distillation is used to separate miscible liquids, right? For example, methanol and water, they use the different boiling points to separate them. B. Solvent extraction. Solvent extraction involves this is where you take advantage of the different solubilities of the component within the mixture, right? And the components are usually immiscible. C. Paper chromatography. This is where you use this technique involves separating, pigments within plants by the force of capillary action up the column within the paper. Part D, centrifugation, is taking advantage of the different densities of the components. So you separate the mixture using the different densities. So the answer that we're looking for would be C. Question 2. The rate of a chemical reaction does not depend on the concentration of the reactants, the presence of a catalyst, temperature of the reacting system, or energy change associated with D. All of the above except D is true. A chemical reaction does not depend on the energy change associated with the reaction. Question 3. Which of the following compounds may be conveniently prepared by precipitation? And if you look at all the options in 3, you will see that they are sulfates and 1 nitrate. So if we use the solubility that all nitrates are soluble, then it's not D, and all sulfates are soluble except barium, lead, calcium, and silver. So the answer that we are looking for would be A. Question 4. Which of the atoms represented below by their electronic configuration will most readily form a positive ion? We have seen this question before, but nonetheless, metals form positive ions, cations specifically. And when you write the electronic configuration, if the valence electron or the valence number, which is the last number in the series, is between 1 and 3, then it is a metal. If it's between 4 to 7, then it is a non-metal. If it has 8 on it, then it is a noble gas. So D is a noble gas and C is a non-metal. 1 and 2 are metals. Okay, now which one would most readily, or in this case more readily, form the positive ion? And the answer for that would be A, because there's only 1 electron on the outer shell, while B has 2 electrons on the outer shell. So you would have to get rid of one first and then give up the next one in order to form the positive 2+ ion. So A readily form the ion. Question 5. Particles in a solid cannot move about because the forces of attraction are very strong. So if you look at the sodium chloride lattice, and you see the attraction between the chloride ions and the sodium ion, and the amount of energy that it requires to break that bond, then you know that's the reason why the solids are so fixed, right? One of the reasons why the solids are so fixed. Part B says particles are tightly packed together, right? Even though solid particles can be tightly packed, they still can vibrate and move about. Particles cannot be easily compressed. That has nothing to do with the question. Particles have a high density. minimal significance regarding the question. So the answer for this is A. Question 6. Which of the following can behave both as an oxidizing agent and a reducing agent? Concentrated sulfuric acid, acidified potassium permanganate, chlorine gas, or hydrogen gas? Now, the thing with this question in particular is that there are no reducing agents right here. None of these options are reducing agents, right? They are all oxidizing agents only. So maybe the examiner made a mistake and should have had, for example, I'm thinking maybe sulfur dioxide should have been right here where concentrated sulfuric acid is. But let us look at why sulfuric acid and potassium permanganate and the others would not be reducing agents. Alright, so let us look at the definition of an oxidizing agent and a reducing agent. An oxidizing agent would be an oxidizing agent cause another species to undergo oxidation while itself is being reduced, meaning that itself is gaining electrons. A reducing agent cause other species to undergo reduction while itself is being oxidized. Okay, look at the structure of sulfuric acid. The formula for sulfuric acid is H2SO4. So that's the formula for sulfuric acid. That's what it looks like. H2, here you have the two H's and the O and the four O's. Sulfur has an oxidation, a maximum oxidation number of +6, which means that in this case sulfuric acid, in the case of sulfuric acid, sulfur is at its maximum oxidation number, which is 6. It cannot lose any more electrons, right? Because if it were to lose any more electrons, then it would be going deep into the inner electrons, and those are extremely stable because they are closer to the nucleus. Okay, so the attraction there is greater. So on the outer shell of sulfur, it has 6 electrons, and in this case sulfur reached that maximum, so it cannot undergo any oxidation further, so it cannot be a reducing agent in this case, right? Sulfuric acid is unable to reduce anything in this case because of the maximum capacity of the oxidation number of sulfur, right? Sulfur can only gain electron in this case, so it can only be an oxidizing agent. Okay, similar feed for the potassium permanganate. Potassium permanganate structure, look at this, look similar to the sulfuric acid, where you have the manganese ions surrounded by 4 oxygen ions, right? And they do that in a what we call resonance. I don't want to go too much into the chemistry that is beyond the scope of this study. Okay, and you have the potassium ion outside. Manganese has a +7 oxidation number, and in this case manganese has reached its maximum oxidation number, which is +7. It cannot lose any more electrons, so it is unable to act as a reducing agent in this case. It can only act as an oxidizing agent. Okay, chlorine gas, which is Cl 2, we know that the chlorine atom, which is the diatomic gas right here, is 0. This chlorine, the diatomic gas, cannot lose any electrons, or else that would split up the molecule. And the same thing for the hydrogen gas. Okay, so I am not sure what the examiner wanted, what were the options that should be here, but I am assuming that if it were SO2, sulfur dioxide, in this case sulfur has an oxidation state of +4. In this case, sulfur can gain another 2 electrons. Sorry, sulfur can lose up to another 2 electrons to form +6, or it can gain electrons, right, to form the sulfur element. Okay, and giving up the oxygen atom to undergo reduction. So I am not sure, definitely not sure what the examiner, the option should be here. So I leave that blank. Question 7, the following chromatogram is obtained from the paper chromatography of a mixture of dyes and 4 separate dyes. Alright, so they are saying that the mixture contains dyes 1 and 2, 1 and 3, 2, 3 and 4, or 1, 2 and 4. Alright, let's look. So for mixture for dye 1, see that they are almost at the same peak. For dye 2, again, very similar peak. Dye 3, we say nothing corresponds with dye 3. For dye 4, almost at the same distance. So the answer would be 1, right there, 1, 2 and 4. 1, 2 and 4, so it's D. Alright, question 8, which of the following aqueous solutions contains 1 mole of hydrogen ions? Alright, sulfuric acid dissociate into 2H plus SO4 2-, so that is coming from the sulfuric acid when it dissociates. This is what ethanoic acid. For ethanoic acid, it dissociates to 1 moles of H plus, well, not exactly 1 moles of H plus, but something less than 1 moles of H plus, and the ethanoate ion, which is CH3COO ion. Same thing for the sulfuric acid right here, 2 moles of hydroxonium ion plus the sulfate ion, and HCl is dissociates into 1 mole of H plus the chloride ion. Alright, so if H plus so here we have our beaker, right, and inside of it we add the volume of water and then the moles of the acid, right? So first we add 2 dm cube of water, and then we add 0.5 moles. Now the 0.5 moles will dissociate into H plus and Cl minus, and since it's a 1-to-1 mole ratio between HCl and H plus, then we expect that the amount of the moles of H plus would also be 0.5, and they're asking for 1 mole, so it's not D. For C, it is again 2 dm cube into the beaker and 0.5 moles of sulfuric acid, which dissociate into 2 moles of H plus and 1 moles of the sulfate ion. Okay, so if it dissociate, if 0.5 moles were dissociated, right, and it's a 1-to-2 mole ratio between sulfuric acid and the H plus ion. So if Here we have 0.5 moles, and over here it's 0.5 times 2. So it is 1. So we end up with 1 mole of the H plus ion dissociated from 0.5 moles of the sulfuric acid. Right? So that would be what we're looking for. Let's look at B. 1 dm cube of the 1 molar ethanoic acid. Now, ethanoic acid don't completely dissociate. So let me draw a double-headed arrow indicating that it goes back to forming the ethanoic acid. So it would be something less than 1 mole. We don't know exactly what. We would have to work out the equilibrium factors and find out what exactly the mole is, but it's less than 1. Okay. For A, so it's not B. For A, it's 1 mole of the sulfuric acid, and remember, sulfuric acid to H plus is 1 to 2. So if 1 mole of sulfuric acid was used, then it should be 1 times 2 for the H plus, which would give us 2 moles, and we're looking for 1 mole. So it's not A, so the answer is definitely C. Question 9. When iron sulfate reacts with aqueous potassium iodide, a brown coloration of iodine is produced. Which of the following deductions is correct? Iron sulfate is a reducing agent. We have seen this question before. Iodide ion has been oxidized to iodine. The iron sulfate has lost electrons. The iodide ion has gained electron. So the iodide ion went ahead and formed the iodine molecule. We know that iodine is a solid. Balance that. So here it was a -1 state and it moved to 0. So the oxidation number was increased. So it was oxidized to iodine. Question 10. Sodium metal contains, we have seen this question again. So that is why it is important, guys, to go over the past papers, right? Because you may be lucky enough to see a question that from previous years on the paper. Okay, sodium ions and mobile electrons, sodium anion and the mobile electrons, cations which repel each other, anions which repel each other. So in the sodium metal, you have the sodium ion that is surrounded by the CF mobile electrons, and the cations repel each other. So that would be 1 and 3, which is A. Question 11. Which of the following statements are true? Isotopes of an element contain the same number of protons. So again, I will use the protium and deuterium. 1, 1 there, right? The same number of protons, that's true. The same number of neutrons, no. Different number of electrons, no. The same number of protons. The same number of protons as electrons, yes. So again, which of the following statements are true? Isotopes of an element, they contain the same number of protons, yes. They contain the same number of protons as electrons. So it's 1 and 4, which is B. Question 12. Which of the following processes suggest that matter is made up of minute particles? And I keep referring to the ammonia gas and the hydrogen chloride gas reaction, where the two of them placed at opposite ends of a tube and allowed to mix, and when they mix, a white solid of ammonium chloride came onto the side of the glass tube, which indicates diffusion, and other factors relating to the particulate theory of matter. Items 13 to 14 refer to the following alcohols. We have methanol here. We have 1,2-ethanol, propanol, and this seems as if it is 2 propanol, propan 2-al. So this seems as if it's propan 2-al. Alright? There are two alcohols with identical molar masses. Which of these two have the identical molar masses? So let us count the number of carbons. So, alright, 1, 2, 3. So we have 3 carbons here. 1, 2, 3, 3 carbons. And the OH. So it says 3 and 4. 3 and 4. That's D. Quick. Which alcohol contains the same number of carbon atoms as methane? Again, methanol would be that alcohol. The difference between methanol and methane is that they substituted the hydrogen for the hydroxy group. So it would be 1, which is A. Question 15. Which of the following statements about chemical reactions is not correct? Energy is given out when bonds break and taken when bonds form. No. Chemical reactions involve the making and breaking of bonds. True. Endothermic reactions take energy from the surroundings. True. Exothermic reaction give energy to the surroundings. So the answer for this would be A. Okay, because to break a bond you need to put in energy. It's like you have a pencil and you're trying to break that pencil. In order for you to break that pencil in two, you have to supply energy to break it in two, right? So to break a bond you have to supply energy. And when a bond is formed, you can think about clasping your hands. When you clap your hands, you feel the air coming, the air that was released when your hands came together coming towards your face. It means that the energy was released. So you can use that analogy when in a situation of doubt or dubiosity. Okay. Question, well, item 16 refers to 1 mole of each of the following acid. Okay, so the acids that we have here are sulfuric acid, ethanoic acid, which is an organic acid, and remember that all organic acids are weak acids, so they partially dissociate. Okay, here we have oxalic acid and nitric acid. Now they said that which two of the above acids require more than 1 mole of sodium hydroxide for complete neutralization. Okay, sulfuric acid, as you can see, it's a dibasic acid, and so because it is a dibasic acid, it will require 2 sodium hydroxide. So every mole of sulfuric acid that is dissociated, it releases 2 moles of hydroxonium ion to neutralize the sodium hydroxide. But we can clear up this with using the formula. So sulfuric acid plus sodium hydroxide give us sodium sulfate, Na2SO4 plus water. Remember, an acid-base reaction produces the salt, which is sodium sulfate, and water. Alright, balance equation, there Na2, so you need a 2 right here beside the sodium. Okay, so you see that it requires 2 sodium hydroxide. Alright, as the question says, more than 1 mole of sodium hydroxide that is required. Okay, part 2, where we have the ethanoic acid plus the sodium hydroxide. Again, you know, we could say ethanoic acid is monobasic, so even though it releases less than 1 mole of H plus, you know, we can say that you would have the sodium ethanoate salt being formed, CH3COO Na plus water. Let me see if I can write that clearer. Na plus water. Alright. For the oxalic acid, this is the structure of oxalic acid. It's like two methanoic acid combining to form oxalic acid. So that's the structure of oxalic acid. So you're going to release this H plus from that part of the acid and this H plus from that part of the acid. So you see that so you need 2 sodium hydroxide to pick up each of them. Okay? And nitric acid, we know that it's 1 mole of H plus it released, so the answer is 1 and 3. 1 and 3, which is B. Items 17 to 18 refer to the following types of substances. Each may be used more than once, or not at all to answer the items below. So here we have salt, we have base, we have alkali, we have acid. Which of the above substances is the oxide of a metal? We know that the base forms the basic oxide and the non-metal forms the acidic oxides. Okay, so metal form the basic oxide, non-metals they form the acidic oxide. Okay, so we know that it is B. So 17 would be B. 18 supplies protons as the only positive ions in aqueous solution, and that's acid. So 18 would be D. Question 19. In which of the following processes is fractional distillation not used? Again, we have seen this question already in the previous past paper. A, refining crude petroleum. Yes. Separation of methanol from methanol water. Yes. Conversion of alkanes into unsaturated compounds. No. Separation of liquid nitrogen in air. Yes. So A, B, and D require fractional distillation. C does not require any fractional distillation. Okay. Number 20. Which 2 of the following are true about electrons, protons, and neutrons in an atom? So we're looking at the neutral atoms. Protons and neutrons are found in the nucleus, right? So yes, that is true. The nucleus is made up of proton and neutron, and that is where the mass of the atom is concentrated. Okay, so when we are talking about the mass number, we're actually talking about the sum of the proton and the sum of the neutrons in terms of their masses. So that's true. Electrons can be found anywhere outside the nucleus. Not necessarily. Electrons can be found orbiting the nucleus. So we'll leave that out. The number of protons always equal the number of neutrons. That's not true. The number of protons always equal the number of electrons in a neutral atom, which is this case. So it's 1 and 4. 1 and 4, which is B. 21. Which of the following is not a mixture? Steel is a mixture. Brass is a mixture. A, B, C are mixtures. Mercury is just it's a metal in the liquid state. Items 22 to 23 refer to the following sets into which elements may be placed. Group 1 elements, Group 2 elements, the halogens, and the transition metals. Select the set of elements which best fits the following descriptions. Each set may be used more than once, or not at all to answer the items below. Alright? Which set of elements has molecules which contain 2 atoms? The halogens. The halogens, they exist as diatomic atoms. Fluorine, which is F2, chlorine, which is Cl2, iodine, which is I2, bromine, which is Br2, and so forth, astenine and so forth. So it's a halogen, so that is C. 23 has atoms with 2 electrons in their outer shell, and that's the group 2 elements, which is B in this case. 24. Which of the following factors would not be expected to determine whether a particular cation would be discharged during electrolysis? So we are looking would not have an effect on the cation being discharged. The position of the cation in the electrochemical series, that's an effect. The concentration of the cation in the solution, that's an effect, with the exception of sodium and potassium, those very reactive ones. The inertness of the electrode, the temperature of the solution, which is D. So the answer is D. 25. Which of the following reactions involve oxidation and reduction? Alright, let's work it out. So here we have magnesium in the 0 oxidation state, and over here it's +2, so that's oxidation. So it had an increase in oxidation number. H plus was +1 right here for the hydroxonium ion, or H plus was +1. Write that properly. +1, and then it became 0 over here. So it was a reduction in the oxidation number. So oxidation and reduction is taking place in 1. In 2, magnesium form M2 plus from 0 to 2 plus, so that's an increase in oxidation number. H plus gain oxygen to form water, so that's also an increase in the oxidation number. The nitrate ion gain electrons to form nitrogen dioxide, so that's a decrease in oxidation number, so that is reduction, right? And another way you could look at it, here we have NO3, down here we have NO2. Remember that reduction is the loss of oxygen. So NO3, the nitrate ion, lost the oxygen to form nitrogen dioxide, so 2 is also 1. Barium 2 plus the sulfate ion. Over here, even though it is condensed, it is still in the +2 state. Both are in the +2 and the -2 states. So this is not part of it. Zinc from 0 to +2. Copper from +2 to 0. So this is both oxidation and reduction. So that's true. So it's 1, 2, and 4. 1, 2, and 4, which is C. 26. Crystals of sodium chloride are best referred to as ionic crystals. Alright. 27. Study the following thermochemical equation. X plus Y equal to Z, delta H equal to -B kilojoules per mole. Which of the following ways can be used to compute the value of -B kilojoules? Alright, remember that to find delta H, the value of delta H, it is the sum of the product minus the sum of the reactant. So it's product minus reactant. Okay, so it's the energy of Z minus the energy of X and Y. The energy of X and Y minus the energy of Z, the sum of energy of X and Y. So 3 is out of it. The energy of X and Y minus, so X and Y are the reactants, and the equation says product minus reactant. So this is out of it. The energy of Z minus X and Y, so it's I. So it is A only. 28. Ferrous chloride or iron chloride and ferric chloride or iron 3 chloride. So it's because the two oxidation states exist. We can use it. We use ferrous and ferric to differentiate between the two, because if I were to just say iron chloride, how would you know unless I use the oxidation state? And since the oxidation state is clearly stated there in a covert kind of way, because we know that when writing the formula we actually switch the oxidation state of the number. So we know that this one right here, it's iron 2, and this one right here is iron 3. So iron 3 is called ferric, and iron 2 oxidation state is called ferrous. Okay, and we know that iron 2 is green and iron 3 is at a reddish brown, a dirty brown looking color. All right, so iron 2 chloride and iron 3 chloride are two chlorides of iron. Which of the following statements about these two chlorides of iron are true? The oxidation state of iron is different in the two chlorides. That's true. One is 2 and one is 3. The percentage of iron by mass in the two chlorides is different, or are different. That is true. But we can work it out. So here we have ferrous chloride, which is iron 2 chloride. So let us work it out. The mass. We want to find out the percentage mass of iron. So it would be, so let us find the RMM of the compound. This is 56, iron is 56 and chlorine is 35.5 times 2. So that's 7 to 1. 56 plus 7 to 1, that's 127. So it's 56 over 127 multiplied by 100. What's the percentage for that? So 56 divided by 127. 127 times 100. So that's 44%. So ferrous chloride is 44% in terms of mass of the iron present, 44%, right? And ferric chloride would be 56 over, so that's 56 over at 35.5, so that would be 162, 35, yes. So it's 56 divided by 162.5 and multiply that by 100 would give us 162.5 multiplied by 100 equal to 34%. So it's 34%. So you see that the mass within the compound is different. So this is true. The colors of the aqueous solution of the two chlorides are different. One is green, one is brown. The aqueous solution of the two chlorides do not conduct. That's not true. Alright, so the answer is 1, 2, and 3. 1, 2, and 3. So that's C. Okay. 29. Sulfuric acid forms the sodium salt, sodium hydrogen sulfate, and sodium sulfate. Its basicity is 2. We know that sulfuric acid has a basicity of 2 because of this is the formula for sulfuric acid, H2SO4, right? And because there are 2 hydrogens here in the formula, it has a basicity of 2. The nitric acid, which is HNO3, because there's 1 hydrogen, it has a basicity of 1. Phosphoric acid, 3 hydrogen, so it has a basicity of 3. Okay, so sulfuric acid is dibasic, nitric acid is monobasic, and phosphoric acid is tribasic. Okay. Question 30. Barium is an element in group 2 of the periodic table. It reacts with cold water to give hydrogen and another substance with formula. So barium, so we have the barium 2 plus water, so you can split up into H plus and OH minus, right? And that will give, so the H plus will go on to form the hydrogen gas, aqueous. Remember that H plus doesn't exist by itself, right? And this is the representation of the hydroxonium ion, which is H3O plus. Okay, so in solution it look like this, and the barium go on and react with the hydroxide. So the negative and the positive, the 2 goes to the OH and the 1 goes to the barium. So it's BaOH2, right, plus hydrogen gas. So the answer for that would be D. 32 items 31 to 32 refer to the following chemicals: zinc carbonate, magnesium metal, barium chloride, and phenolphthalein. In answering items 31 to 32, a particular choice from the above may be made more than once, or not at all. Which of the chemicals above can be used in an acid-base titration to show that the reaction has been completed? And we know that that is phenolphthalein. Acid-base reaction, it changed from the colorless to a faint pink. 32, in aqueous solution produces a white precipitate on the reaction with sulfuric acid, and we know that that would be barium chloride, which is C. Items 33 refers to the table below, which gives the melting point and boiling point of the following chlorides of 4 elements. Alright, which of these elements would most likely form a chloride that is ionic in nature? We know that ionic compounds are extremely, they have a very high melting point and boiling point. So the one with the highest melting and boiling point would be indicative of the ionic compound. Okay, and so that would be 3, which is C. 34. Items 34 to 35 refer to the following items: isomers, polymers, allotropes, isotopes. Match each of the following descriptions with one of the items above. Each option may be used more than once, or not at all. 34 says solid forms of a given element which differ in physical properties, and that is a allotrope. So in this case it is C. 35. Compounds having the same molecular formula but different structural formula would be isomers. Same molecular formula but different structural formula. So that would be A, the isomer. Alright. 36. Which of the following element reacts most vigorously with H+ ion to give hydrogen gas? And based on the list right here, it is zinc. A. Potassium is a metal. From this information only, it may be deduced that potassium is soft, is very reactive, has a low melting point, is a good conductor of electricity. From this information, I would say the answer is D. Well, the answer is D. It's between B and D. Now, we know that potassium is very reactive, and if you were to take potassium out of the equation and just say a metal, would you say that all metals are reactive? That's not true, right? But can we say that all metals are conductors of electricity? Of course. Okay, so that's the logic behind it. So the answer is D. 38. Item 38 refers to the Haber process for the production of ammonia according to the equation, where we have nitrogen gas plus hydrogen gas to give ammonia. The catalyst used in the process is iron. We know that the Haber process is catalyzed by iron. 39. When copper 2 carbonate is heated alone in a dry test tube, a gas is evolved and a black residue is formed. This gas is expected to do what? So we know that the black residue is copper oxide, and the gas evolved is carbon dioxide. Okay, now we know that carbon dioxide will react with calcium hydroxide or lime water, turn it milky or cloudy, which is the white PPT that forms. 40. Which of the following aqueous solution will produce a blue precipitate with aqueous sodium hydroxide? Back to qualitative analysis, where we add sodium hydroxide and a blue PPT form, and that was an indication that copper is present. So it would be copper nitrate. 41. Which of the following gases are classified as pollutants of the air? Nitrogen, we need nitrogen. Nitrogen is clean. Carbon monoxide is poisonous. Hydrogen gas, though explosive and so forth, it is okay. It's not a pollutant to the air. Sulfur dioxide forms acid rain. So it's 2 and 4. 2 and 4, which is B. 42. Many fertilizers contain ammonium salts because these salts are very soluble in water, improve the texture of the soil, dissolve to give acidic solution which keep away pests, or are a source of nitrogen which is essential to plant growth. And that's D. 43. Which of the following neither reacts with water nor replaces hydrogen from dilute hydrochloric acid? And that's copper, because copper is below hydrogen in the reactivity series. 44. In the reaction between zinc and dilute sulfuric acid, water is formed? No. An insoluble salt is formed. Zinc and zinc sulfate is soluble, so that's a no-no. Neutralization occurs, that's a no-no. So the only one would be an oxidation, a redox reaction taking place. Oxidation or reduction. Okay, where zinc metal oxidized to zinc 2+, and the hydrogen gas forms. 45. Which of the following are arranged in order of increasing the particle size? The particle size. Colloids, solution. Well, all right. Solution would if there are any particles, would be the smallest, extremely smallest. All right. Followed by the colloid, followed by the suspension. So that would be solution, colloid, suspension, and that's D. Alright. Items 46 to 48 refer to the following organic compounds: ethanol, ethene, ethanoic acid, and ethyl ethanoate. In answering items 46 to 48, a particular choice from the above may be made more than once or not at all. Which of the following organic compounds undergoes addition reaction? Ethene would undergo addition reaction, so that would be B. So that would be B. Is immiscible with water and sweet smelling. From the mentioned sweet smelling, you know that those are the esters. So that is D. Reacts with hydrogen to produce an alkane. So ethene undergo hydrogenation to produce the alkane. So again, that is B. So 48 is B. 49. The compound ethene is described as being unsaturated. This means that A. Carbon atoms in ethene are linked by single bonds. No. Molecule has insufficient hydrogen atoms. Carbon atoms in the molecule are very reactive. No. The molecule contains at least one double bond. Alright. So unsaturation means that the compound is unsaturated with hydrogen. Okay, so hydrogens were lost and an extra bond formed to take the place of the hydrogen. So you can look out for that. So it's not fully saturated with hydrogens like the alkanes. Okay, however, the answer would be D. So unsaturation means that a double bond is present and it's not fully saturated with hydrogen. So where the hydrogen would have been, a double bond is there between the two carbon atoms. Alright. 50. Which of the following is not true of all homologous series of the compounds? The members of the series have the same functional group. Yes. So think of an alcohol. So all the members of the homologous series for the alcohol contain the OH group. They have the same general formula. Yes. CnH2n plus 1 OH. Similar chemical properties. Yes, you would expect all the alcohols to react the same way. Do you expect them to have the same empirical formula? No. So 51 is D. Sorry, 50 is D. 51. Which of the following types of polymers may be derived from compounds like the one below? So this is an amino acid. So we have the amino group and the acid group. So it is an amino acid, and the amino acid react to form polyamides. So that's A. 52. The process by which large molecules of hydrocarbons are broken down into smaller molecules is called cracking. So we use cracking to break down the larger hydrocarbons into smaller ones. And there are two types of cracking, of course: thermal cracking and catalytic cracking. 53. The fermentation of sugars using glucose as the substrate can be represented by the equation. Which one of these equations would represent glucose? Glucose, so it's C. C6H12 give ethanol and carbon dioxide. So that is C. Okay. Items 54 to 55 refer to the following diagram, which shows how apparatus and materials are used to identify the products formed when ethanol burns. When ethanol burns in oxygen, it produces carbon dioxide and water. Alright, so those are the products that we're looking for. Now 54, it says, which of the following best describes what will be observed in the U-tube and the test tube at the end of the investigation? So in the U-tube we have the ice pack. So water and carbon dioxide is produced. So steam is cooled to water, it's condensed to water, and we see again carbon dioxide best friend, calcium hydroxide, that is used to test the presence of carbon dioxide. So it's D. So it's water and carbon dioxide. 55. If the ice were removed, which of the following would represent the equation for the reaction? Alright, let's see if we can balance if this is balanced. So this is 4 carbon, 2 oxygen, 7 2 is 14, so that's 16 oxygen. Oxygen over here is 4 and 2, 8. 8 and 6, 14. 2 hydrogens over here. Well, 2, that's 10. 11. sorry, 10 to 12, so that's 12 hydrogens over here, and so we also have 12 over here. This react, all right, so the 7 should be 6, so these should be 6s, okay. Yeah, so it should be 6 rather than 7. Now, if the ice were removed, then we would have steam being formed instead of the liquid, right? So in the case of if in the case of the ice, we get A. In the case without the ice, we get B. Okay. No, sorry, B as L right there. So I was looking out for the state symbol. We should be aqueous, so it's D. So the answer is D. Ethanol is aqueous, and plus the oxygen gas, plus carbon dioxide gas, plus water in the gaseous state for steam. All right. 56. The functional group present in carboxylic acid is C double bond O OH. C double bond O OH. Where is the functional group present in carboxylic acid? C, okay, right here. They redrew the structure differently. C double bond O OH. So that's B. (57) Which compound is not considered to be a polymer? Alright, so amino acids are monomers. They are precursors for polyamides or proteins. 58. The major natural source of alkanes and alkenes is petroleum. Alright, when petroleum crack up, they produce both alkanes and alkenes. Item 59 refers to the following information. Chlorine is bubbled into aqueous potassium iodide mixed with a few drops of aqueous starch in the apparatus shown below. Alright. What will be the color of the solution in the test tube when the chlorine gas stream has stopped? If we use potassium iodide, or if we use iodide or iodine on starch, we should expect a bluish black color. Okay, so the answer would be D. And question 60, a polymer has the partial structure. Okay, so here we have the partial structure of the polymer. The formula of the monomer would be, so it has to be an alkene, so it's between B and D. And if you look at B, you see that the carbon is showing 5 bonds, so this compound doesn't exist, so it has to be D. Okay, so we have come to the end of this video. Thank you for watching, and don't forget to subscribe, like and share. See you soon.